like to introduce my new module, the triangle core voltage controlled oscillator. It's fully analog, contains two identical VCOs. Each oscillator is based on super stable analog SSI2130 VCO IC, served by 46 opamps. In total there are 34 analog ICs and 449 other parts. In analog VCO, sound wave is generated by charging and discharging precision capacitor, controlled by a temperature compensated exponential converter. Generated triangle wave then goes to wave shapers, producing different waveforms. Such technology produces supreme audio quality. Pitch is tuned to standard 1 volt per octave. Oscillator provides excellent tracking across 10 octaves. It can be tuned with precision of ±1 cent or 0.01 semitone. This is very precise, as human ear can detect the tuning from around 3 to 5 cents. Here I have a module that converts MIDI to analog pitch. Pitch then goes to precision copy module, which provides 3 buffered copies of the same signal. One goes to the filter and the other one to the oscillator. So let's plug it in and play a couple of notes. When pitch cable is connected to the left side, it is forwarded to the second oscillator on the right. Connecting different pitch to the right cuts this connection. So if you only need one oscillator per voice, module can be configured to play 2 separate voices, each going to the dedicated filter, VCA and output. Each oscillator outputs simultaneous sine, triangle, saw, and pulse waves. Mix output provides voltage-controlled mixing between triangle, saw, and pulse outputs, controlled with dedicated knob or -5 to +5 volt CV. Square wave has pulse width modulation, which can be controlled by potentiometer and CV. Mix output also offers a sub-oscillator controlled by a sub-knob. Sub-oscillator provides square wave and octave below. On back side of the module I have added jumpers to turn sub-oscillator by 90 degrees according to taste. Both sub-options sound a little different. For demonstration, the right oscillator is turned by 90 degrees and the left one is not. Each oscillator has tune and octave knobs, also fine-tuned for precise tuning adjustment. Octave switch is very useful when looking for the right tone. It has 5 options, -2 to +3 octaves. Harsh saw and square tones are usually used with the low-pass filter. This is called subtractive synthesis, where harsh harmonics are removed to a certain degree for more pleasant tones. Module also has main mixer output controlled by mix knob. It provides crossfader between the 2 oscillators. When oscillators are slightly detuned, we can achieve richer tones. This is due to wave interference. Same waves sum up and opposing waves cancel out. This interference can be seen in the intensity of the LEDs. To remove this interference movement, module provides 2 sync options. We need to take the signal from square wave and connect it to the sync input of the other oscillator. Hard sync resets the oscillator wave to 0 and soft sync resets the wave backwards, producing softer tones. With 2 oscillators we can also do different kinds of FM synthesis. This is achieved by modulating frequency of one oscillator with input from another oscillator. For this we usually use softer symmetrical wave shapes. Each oscillator has FM modulation output, which is basically sine wave with output gain controlled by a potentiometer. This potentiometer is often called modulation index. In the module I have it simply called FM. So let's patch cable there and plug it to exponential FM input of the second oscillator. Turning the FM knob creates frequency modulated tones. Passing such output to envelope controlled low pass filter, we can produce all sorts of bell sounds. By changing octaves of the first and second oscillators, we can generate many different bell timbres. These bells sound much better with added stereo delay. We can also spice it up by detuning one or both oscillators using tune knobs. Exponential FM is not very musical because it detunes the output pitch. Good for percussive sound and not very useful when playing melodies. This is because such FM modulation works on exponential scale, and positive modulation swings have different frequency relation compared to negative ones. To play FM melodies without the tuning, we have different linear FM options. As name states, linear FM affects frequency in the linear way, meaning that positive swings have the same frequency difference compared to negative ones. This is true for modulation index of about 50%. When the knob is turned higher, low frequency swings reach 0 Hz and cannot go beyond, creating difference in positive and negative frequency swings, and therefore generate the tuned tones. To combat this, module also offers Thru-Zero linear FM modulation option that can go beyond 0 Hz. When modulation index is increased to swing below 0 Hz, the wave starts to go backwards, creating negative frequency that compensates the symmetry and the pitch gets maintained. There is also a Thru-Zero phase modulation input designed to maintain pitch when modulating with asymmetrical waveforms. Apart of modulating one oscillator with another, we can also do FM using LFOs or envelopes. Here's a quick example. With 3 or more oscillators, we can patch more complex FM. First oscillator can be patched to modulate second oscillator, then second one modulates third, or we can leave the 2 oscillators unmodulated and use their mix to modulate a third oscillator. These are just a couple of ideas. Possibilities are truly endless. We can do linear and exponential FM at the same time, connect different sound sources, use variable modulation index by processing the modulation signal with envelope and VCA. All inputs and outputs are ruggedized, so you don't have to worry when connecting signal to the wrong connection. Stay tuned for more high-tech modules from LFusion Electronics.